Okay, here to do the labs for the AC to DC. Now the first lab is involves the bridge. We'll do a simple part, the two circuits demonstrated in the lecture, or at least discussed in the lecture. But this one I'm going to just call part 1. And you can follow in and fill out the fillable lab form that I've already sent you. And in this first part, I'm just going to review the diode characteristics, which you've done actually a couple of times now, but also move on to the first of the two diode circuits, the half-wave rectifier, where it's just a simple diode in a with a series resistor. Then I'll do a second demo tape that is the bridge rectifier and only the bridge rectifier. So I'll do the setup here, which includes the oscilloscope and all that, and we'll get set up and running, and then add the second part, which is the bridge. All right, so I'm going to bring in the experiment itself. You have this in the fillable PDF form. Maybe I can shrink this a touch, might not need much. And then we need to get our scope going here. I'll bring on a picoscope. And we'll get that set up. Would be good to plug in the device first. See what happens. Here we come. We're familiar with this screen that shows this. And shrink that a little. And I'm going to then lower the camera so you actually see the parts. More important than seeing me. And I'll put a good background over here. And I'm going to bring back the transformer. Now, a couple of things you'll notice right away. In the experiment, it's the first part of it is simple. This first part is a repeat. We've done this 2 or 3 times already. The digital multimeter in diode mode, we've done this. And when you forward bias the diode, the multimeter reads, it should be something in the neighborhood of 0.6, 0.7 of a volt. You've measured this even in the lab before the break, I know. And when we reverse the leads, what do we get here? We get an OL, open loop, okay? And you can mark these. Now let's go to part 2, where we're going to deal with this half-wave rectifier here. Well, you'll eventually be asked to draw the picture too. You do the usual picture and put a photograph here thing, but let's just do the experiment, and here it is. Now, the only difference between this and what we talked about, or what I talked about in the lecture for AC to DC, is I've added this transformer in here. And not only that, but I added it backwards of what you're used to thinking. So if you think back to the experiment on transformers, you may remember we plugged in some volts, 2 volts, and when we put 2 volts on this side as the primary, in other words, I had it like this, and here's the 2 leads that are generally the primary, and here's the 3 leads. I've rolled one of them up out of the way because it's going to be a no connect today. All right, now when we did this, we applied 2 volts here, and we got 0.8 of a volt out of here. Okay, and so we calculated a ratio there, and it was like 0.4, so that was that. We could also, we got 0.4 of a volt here, so we could have used that. All right, now the reason I do this is because I've inserted the transformer here, is because the best I can do from my signal generator, I'll bring this down some more if I can, the best I can do with my signal generator out of the the AWG line is 2 volts. So I'm going to give it full power there. But when I get to this side, if I put 2 volts across this circuit, 7/10 of it is gone right there. So it's going to look kind of mushy. So in my case, the whole purpose of the transformer is to increase the voltage from 2 volts to something more than 2 volts. And we calculated the gains there, and it was like 2.5 and 5. So I'm just going to use the 2.5 number. So I'm going to expect this 2 volts when I attach it to the 2 outside pins of the 3-wire side, in other words, orange and red. I'm going to expect to see something like 5 volts coming out of the yellow wires. So I'm going to orient this. You're seeing the screen backwards. I'm going to orient this and connect the power, the signal source onto there in the usual fashion. And another nice thing we get out of doing it this way, putting the transformer in, is for measurement, it isolates the 2 sides of the circuit, so I don't have grounding issues, which you come to appreciate after a while. All right, so I've attached the signal, and you know what? I'm gonna put a scope on that. Now I don't need to attach the black here because I'm really just putting on an oscilloscope probe on that one side. Hopefully that's all stuck together, and of course it didn't. The wire stayed, but all right. So I just connected those together here. I can move this over a little bit. You can see better. All right. So all I've done is this right here. I've wired this up to these outside pins, and I'm watching that signal. So let me put it on AC and turn it on. I think that signal is going to be 2 volts, so I'm going to turn it on to that. But right now nothing's there, so let me go to my signal generator and call out a sine wave of 2 volts. And I'll go down there to 100 hertz, where we've been working. Kind of standard for us now. And I'll turn it on. So the reason it's wobbling, of course, is because we're looking at it way too fast. We got to slow this puppy down and put a trigger on it to stop it from jumping around. Okay? So there's our input signal, a little bit less than 2 volts. And there's an explanation for that, but it's not, we don't need to worry about that here. It's pretty much, for the most part, 2 volts. One thing I'd like to see before I go any further is, what does the signal look like here at what I've labeled V source? So I'm going to put the second channel over there, like that, and turn on a second channel. It's off, so let me turn it on, and I'm anticipating good voltage, so there we are. So there's my now I reversed primary and secondary from the last experiment. It looks like I'm wobbling around with my weak connections here. So right up here is 5 volts where my pointer is. So I'm coming in a little less than 5 volts, but I went in with a little less than 2. So if I divided this number, which is 4.367, if I divided, you could call that 4.4 maybe, yeah. If I divided that by this number, which is 1.8, I might have about a multiplier of 2.5. So what I've done is just made a real simple step-up transformer. Same transformer I had before when I stepped down. If I go this way, I'm stepping down. If I go that way, I'm stepping up. It's just the turns ratio of the transformer. Now I'm going to finish this by simply adding the diode and a resistor. And almost any size, good size resistor here will work. So let's put some values in here though. The source voltage, it's the one I labeled, not the 2 volts. It's this one over here. The source voltage is what? 4 point something, 4.4 peak. So we could measure with the multimeter the RMS values, or you could calculate it by multiplying by 0.7. And what is this? The resistance. I'm not sure what that resistor is, probably just this one out here. Okay, so I'm going to want you to draw your oscilloscope traces, label axes, and so forth, and then answer the question, is the signal rectified? Now I'm going to put the traces up here on the scope. Give me a moment to assemble the circuit, bring it in. Actually, I've got it right here. And I deliberately picked a large diode like you're used to using, and a good size resistor here. I think I actually, instead of 22K, picked 5.9 or something like that. 59K. I'm not sure. It's just big enough, I know that. All right, so I have the diode in. You won't be able to see it, but there's the cathode and there's the anode. So now I'm gonna just connect. I don't want to see this second right now. I'm going to connect the secondary circuit into, of course I am, into the circuit board here. Fat wires are giving me a hard time. Let me just get some needle nose here and jam it in, because getting a good connection is pretty important, even getting any decent results. Doesn't matter what you're doing. Okay, so now I've got that plugged in. And it doesn't matter which way those go, because the phase is going to make up its own. All right, now it wants us to plot. It wants us to plot the source voltage and the output voltage. So let me move the source. I'm going to move the blue leads over here to, I'm going to find some nice hard points to clip it on. Right there on the bottom of the transformer. Okay, so now we got that big 5 volt number on the input, so I better crank this up one. So that's the input there now. That's our value right over here, and I've loaded it down a little bit, so it's getting feeling the effects of that. But anyway, that's the signal. Now what I want to look at is what's the V out signal. Okay, and I've already attached one black lead, so all I got to do is come over here and connect to that, and look at there. There's our half wave rectifier. Whenever the input signal, follow the blue trace, goes positive, the output signal goes positive following it. This little gap in here, that's the amount of voltage that's lost across the diode. And even though it looks like they're getting further apart and then back together, if you measure the vertical distance, it's always that 6 or 7/10 of a volt. Okay, maybe we could just check it here even. Here, I'll pick 2 points on the line. So it says the value is 3.133. And now if I measure the other one, it says 2.563. So 2.56 minus 3.1 minus 2.56 is, 6/10 and some change. So that's what's there. I could measure at other places, you'd get the same thing. But so that's just the diode drop that you're seeing there. Here it lies nice and flat at 0. So what have we got? This voltage, this circuit converted something RMS to something DC. So maybe to finish this out, what we really want to do is pull in our multimeter again and just give this a good checking out with that. See if I can get this into the picture. Right there. So what do we want? We want some AC measurements. So I'm going to turn it on voltage and tip it over to AC. So the first thing I've got AC and I got 0 volts. So here's the source voltage right now. Here's the source voltage at AC, 2.613. Now that is RMS right here. It's RMS right here, 2.613. Okay, that's the RMS value of this blue signal. That's what's going on there. Is the signal rectified? Use your multimeter on VDC. What's the output voltage? Now this is going to be interesting because now I put it on DC, right? The DC voltage is going to be, we'll write that here. Do you think there's even going to be any DC? This is not a straight line. Be interesting to think if is DC. If you follow the blue line, there's no DC because it spends as much time above the line and below the line. The average of that is 0. The red one's going to be different because it only spends time above the line. But it's not DC. It's just some number. So here's what that's going to measure. Doesn't look like much, huh? On DC. Yes, I'm measuring DC. What's the output voltage on DC? Boy, pretty scarce, isn't it? There's nothing going on there. Right? Actually, there is stuff going on. You see it on the scope. It's red. But it's not making DC. Now, if we put a capacitor across that in a simple form, and maybe before we leave this, I will do just that, and then we'll see if we get a little DC. Kind of interesting. Some of this has to do with the way that meter measures. It's not able to actually calculate a type of DC. So I'm going to grab a little capacitor here. I'm just curious now. And I'm going to hold it in here. You see how that flattened out? Oh, it flattened a lot. So it really messed the circuit up a bunch. You can't just throw that in there automatically. But we did get some DC out of it. You can kind of see the red line. The red line on there is like 1.5 volts or something like that. This might be interesting. I don't know if I can hold the meter and all of this at the same time, but I'm going to try. Still doesn't, I may not be holding wires tight here. It's going to be funny how the meter actually measures. So we didn't get any DC out of this, but that's how that circuit works. So I'm going to call it quits on this one. Come back with another video. You can draw this picture right here, and your labels are, here they are, 2 milliseconds per division, horizontal, that's the time division. So each one of these little spaces here is 2 milliseconds. And the vertical is 1 volt per division. Right? 1, 2, 3, 4, 5 volts top. Okay? So you can just draw that in, and you can stall the video and draw that in, and then you'll take a picture of it and install it. So I'll be back with another video to do the bridge rectifier.